Okay, let's unpack this.
Let's do it.
We are diving into one of the most persistent, maddening, and frankly, just absolutely fascinating questions in all of philosophy and science. What is it like to be?
We're tackling consciousness.
Mm.
And not just the mechanics of how the brain works, but, how the brain feels.
Exactly. And our sources today are going to take us pretty far afield. We're pulling from foundational philosophy, some really bleeding-edge neuroscience, AI skepticism.
And even into the really intense ethical challenges you see in modern bioethics. It's a huge landscape.
It is. So I think our mission for this deep dive is, well, it's ambitious. We want to explore this whole concept of subjective experience, how profoundly it depends on perspective.
And the big one, whether modern science with all its amazing brain mapping tools and supercomputers can ever truly bridge that gap.
The gap between the objective, measurable physical facts and that irreducible inner feeling that kind of defines all of us. We're looking for those nuggets to let us know where the cutting edge of this research really is.
And to do that, we have to begin our journey where really all serious discussions about consciousness have to begin.
Which is where?
With a nocturnal creature whose entire existence just throws this massive wrench into the machinery of scientific physicalism, we have to start with the bat.
That's right. Thomas Nagel's incredibly influential 1974 essay, What Is It Like to Be a Bat?
An essay that is, 50 years old now? And it's still the gold standard for challenging the limits of scientific explanation when it comes to the mind.
It's important to say he wasn't just, being cute or choosing a random animal.
No, not at all. He chose the bat for a very specific reason. Its primary way of sensing the world echolocation is just completely alien to human experience.
It's a totally different way of building a model of reality.
Exactly. So that brings us to the core question. What was Nagel's genius insight here? Because on the surface, it seems almost deceptively simple, just asking what it's like to be a bat, but it just cracked the entire field open.
Right.
Well, the core insight is this. Even if we could achieve perfect, just encyclopedic knowledge of the bat's biology.
Now, by perfect, you mean literally everything.
I mean everything. Let's say we map its echolocation system down to the last synapse. We understand every single neuronal firing pattern. We know its physical state down to the atomic level, every electrical and chemical process.
A complete, objective blueprint of the bat.
The perfect blueprint. And Nagel's central point is, even if you have all of that, you still cannot grasp the subjective character of experience. You cannot know what it is like to be that bat.
It's like having the full schematic, the wiring diagram, and the maintenance manual for, a high-end microphone.
Right.
The manual tells you exactly how it works, but it can never tell you what it's like to actually experience the beautiful, complex music that was recorded through it in a specific concert hall.
That is a perfect analogy, and that subjective feeling is what philosophers call qualia. Nagel's central claim, then, is that this what it is like quality is fundamentally perspective dependent.
Okay, so it can't be fully reduced to objective, third-person, physical facts.
Precisely, because those facts, by their very nature, strip away the first-person perspective that defines the experience in the first place.
But wait a minute. If you're a strict physicalist, someone who believes everything is purely physical, why should that perspective matter? Shouldn't a complete scientific explanation be objective? If we can perfectly simulate the physics of the ultrasonic wave hitting the bat's auditory cortex, isn't that enough?
And that is the exact challenge Nagel was posing. Scientific physicalism has always operated on this principle of reduction.
Breaking things down.
Breaking things down to their simplest physical components, but consciousness just resists that. You could perfectly simulate the physics, sure, but that simulation only tells you how the physics work. It doesn't tell you what it feels like for the bat to construct a three-dimensional map of the cave entirely out of time-delayed echoes.
The reduction removes the experience itself.
It removes the very thing you're trying to explain.
So this deep dive is really about demanding a higher standard for how we study consciousness. It's about recognizing that science's current toolbox, which is, spectacular for objective physics,
Absolutely.
it just hits a wall, the wall of subjective experience. And this is the important part. Recognizing that limit isn't a call to just stop trying.
No, it's a demand for a better, a more expansive framework for how we continue to study the mind. So let's spend a little more time staring at that wall, because it really does define what all of consciousness research is up against. It's what's known in the field as the explanatory gap.
The explanatory gap, which is, I guess, simply the gap between physical processes, like neurons firing, and the subjective experience itself.
Precisely. Physicalism has been just wildly successful in explaining mechanics, gravity, chemistry, genetics, how neurons transmit signals, but it struggles, and I mean really struggles, to explain how this wet, gray clump of neural tissue in our skulls generates a conscious, felt experience.
We can see the information processing happening, what it does.
Yeah. We can see that perfectly. But we fundamentally lack the conceptual tools to explain how that processing transforms into the subjective feeling of seeing the color blue, or tasting chocolate, or feeling a sense of dread.
And this is where Nagel's bat finds a perfect conceptual partner in crime, one that really helps highlight that gap.
The philosophical zombie.
The pea zombie.
Right. It's a concept that was really popularized by the philosopher David Chalmers, and it's sort of a conceptual twin of Nagel's bat. If the bat shows us the limits of knowing other minds, the pea zombie shows us the conceptual possibility of a mind that's physically identical to ours, but completely empty inside.
Okay, so define the pea zombie for us again, but with an emphasis on what makes it so problematic for a strict physicalist view.
All right. A pea zombie is a hypothetical being that is physically, chemically, and behaviorally identical to a human being. On the outside, you cannot tell the difference.
So their neurons fire in the exact same sequence. They produce the same hormones.
They walk, they talk, they laugh, they react just like a normal human. However, and this is the crucial part, they lack any inner subjective experience. They lack qualia.
There's no one home.
There is no one home. So when a pea zombie steps on attack, its nervous system registers the sensory input, its brain sends a pain signal, it retracts its foot, and it might even emit a perfect, socially appropriate ouch.
But it doesn't feel anything.
It doesn't feel that searing, subjective quality of pain. There's no internal suffering. It's just a complex, convincing reflex.
This is a really deep conceptual challenge, because the common problem shared by both the bat and the zombie is that in both cases, you can account for all the third-person physical facts, all the objective data you could ever measure.
And yet something crucial, something essential is still missing.
The first-person experience.
That's the core realization. The standard physicalist explanation treats the brain as just a complex but purely mechanical system. The pea zombie shows that if you only look at the mechanics, you might be missing the consciousness entirely.
So both concepts show that first-person experience cannot be reduced by third-person observation. The scientist observing the brain from the outside.
The third-person view.
Can never truly access what the brain is feeling from the inside.
The first-person view. The gap remains.
Now, to make this distinction even clearer, our sources bring in this really useful framework from a book called The Mind Club. It separates how we perceive minds into two core dimensions that, we use all the time without even realizing it.
That's right. The two dimensions are experience and agency.
Agency and experience.
Agency is about a being's capacity to act, to plan, to have intentions, to exert self-control. It's about doing things in the world.
Behaving like you have goals.
Exactly. And experience is about the being's capacity to feel, to desire, to suffer, to have qualia. It's the inner life.
Okay, so if we take our philosophical creatures, the bat and the zombie, and place them on this spectrum, it should give us some immediate clarity.
It really does. The pea zombie is defined as having extremely high agency. It does everything a human does perfectly, but zero experience by definition.
It's pure function without any inner light.
An empty machine. Now, Nagel's bat is different. We assume the bat has a rich inner experience. It's a living, conscious creature, not a zombie. The problem is that our limitation is we cannot access the content of that specific experience.
And this distinction is so critical because the bat isn't a zombie. It is experiencing something. But Nagel's profound critique was that by reducing the bat's subjective world, that feeling of navigating by ultrasound, to just a list of dry, objective data points.
Science was effectively treating the bat's experience as if it were just a physiological input-output response.
You're treating it like a zombie's mechanical reflex.
Yes. It reduces a rich inner life to a checklist of data, and in doing so, it misses the essential quality of what it is like to be.
So the point of the bat wasn't a surrender. Nagel wasn't just throwing his hands up and saying, well, we'll never know, so let's stop trying.
Absolutely not. His work was a demand for methodological humility, and it was a call for a completely new scientific approach. He suggested we need to develop something he termed objective phenomenology.
That phrase still sounds like a contradiction in terms to me.
Yeah.
Objective measurement of subjective experience. How on earth do you even begin to do that?
Well, the idea is that we stop trying to describe experience purely through these low-level components, like neuron X fires when it sees red. Instead, we need to move to a higher level of conceptual abstraction.
Okay.
We need to create new conceptual tools, maybe a new kind of language or a new mathematics or new ways of diagramming things to describe the structure of subjective experience objectively, even if we can't access the feeling.
So instead of just cataloging the firing patterns, you try to map the structural complexity of the bat's internal world?
Exactly. You'd look at how it organizes spatial awareness based on time delay. You'd ask how its perception of the flow of time might differ from ours. How are all its sensory inputs organized into a coherent, functional, internal world model?
You're mapping the shape of the container, even if you can't taste what's inside.
That's a great way to put it. We may never feel what it's like to be the bat, but perhaps we can mathematically or structurally map the organization and the complexity of its experience. And that would allow for cross-species comparisons that respect this perspective dependence while still demanding real scientific rigor.
Okay, so let's take this out of the purely philosophical realm and bring it into the operational sphere, because this is where it gets, for me, really interesting. We're about to take that fundamental philosophical problem, the irreducibility of subjective experience, and just slam it straight into the most cutting-edge technology we have.
We're talking about brain-computer interfaces, BCIs.
Things like Neuralink.
Right. And the recent successes in BCI technology, particularly in medical applications, they're genuinely revolutionary. We've seen these incredible successes in enabling quadriplegic patients, people who might have been paralyzed for decades,
To regain control.
to regain functional control of cursors, tablets, and even robotic limbs, all using these tiny chips implanted in their brains. It is a monumental engineering achievement.
And naturally, this success is often held up by futurists, most famously someone like Ray Kurzweil, as proof. Proof that we are on the road to the singularity.
The point where human and machine intelligence merge completely.
And possibly allowing for that ultimate dream, or nightmare, depending on your view,
Yeah.
uploading human consciousness into a digital computer.
But we have to look really critically at why these current BCI successes actually work. They work because they rely entirely on solving what David Chalmers would call the easy problem of function.
The easy problem.
Their success is totally dependent on the precise localization of specific modular functions within the brain.
And the motor cortex, where they implant these things, is perfectly localized.
It is, thank goodness. The brain's motor and sensory areas are clearly mapped out. You might have seen that old drawing of the homunculus.
Oh yeah, the creepy little man with the giant hands and lips stretched over the brain.
That's the one. It's a distorted map of the body stretched across the sensory and motor cortexes. And because that motor area is so clearly mapped, the BCI can act as a perfect translator. It translates specific, localized electrical signals from that one region into reliable input-output commands.
Signal A means move the cursor up. Signal B means click.
It's a purely functional success. It's mapping signal A to movement B.
Okay, so if we can successfully localize and control movement, why can't we just localize and control consciousness? Why not just fulfill Kurzweil's vision of the singularity by, I don't know, inserting enough chips in enough places?
Because the leap from functional BCI success to uploading or completely integrating human consciousness, that's where the fundamental philosophical flaw lies. That leap completely ignores the hard problem of consciousness.
And here we are again, coming right back to the fact that consciousness is not neatly localized to a single chip insertion point like the motor cortex is.
Exactly. The dominant scientific theory right now, which is supported by frameworks like global workspace theory, suggests consciousness is an emergent phenomenon. You can't locate it in one spot because it's the result of the entire system's operation, not a single component within it.
Can you explain emergence in this context again, this idea that it's more than the sum of its parts?
Sure. Emergence means that consciousness arises not from any single neuron or any specific anatomical spot, but from the complex, high-speed, networked interaction of the entire brain. It's a property that just appears, that comes into being, when the system reaches a certain threshold of complex integration, a property that is greater than the sum of its individual parts.
This is where our expanded orchestra analogy really helps to clarify things.
It does. Think of the brain as a massive, world-class symphony orchestra playing this hyper-complex, emotionally intense symphony.
Good.
Neuralink's success in the motor cortex is like connecting a single, very effective microphone to one brilliant violinist who's playing a very precise solo part.
And that microphone lets me hear the violinist perfectly. I can understand the function of that one instrument, how the bow moves to make a specific note, which then translates to a cursor movement.
Exactly. But, and this is the key, capturing the sound of that one violinist doesn't capture the entire orchestra's harmony. It doesn't capture the atmosphere in the hall, the emotional depth of the symphony, or the feeling of being surrounded by that music.
And that overall harmony, that feeling,
Yeah,
that's consciousness.
that is consciousness.
Yeah.
So if consciousness is emergent, simply implanting a few chips provides functional integration, you gain enhanced computation, maybe you can access internet data, you get physical control. But it does not guarantee ontological integration.
Ontological integration. You mean the actual fusing or merging of this subjective self?
Yes, the two selves don't become one.
So this is where we can bring that mind club distinction back into play. The BCI gives the user vastly greater agency. They can do things they couldn't before.
Unquestionably.
But is the subjective experience of the user actually merging with the AI? Is the feeling part coming along for the ride?
This is where you risk creating the ultimate hyper-capable cyborg P-zombie. You're creating a system with massive functional capability, infinite agency perhaps, that is simply connected to a biological system. But if that AI is just a pure prediction processing engine without the necessary biological substrate to generate subjective feeling,
Then the fundamental gap is still there.
it remains. The connection just links your biological feeling brain to an incredibly powerful but non-feeling external calculator.
So if I connect my brain to a super AI that instantly shares all my data, all my memories, and processes my thoughts a million times faster, the question is still there. Does the AI feel my anxiety? Does the AI share the actual feeling of my pain?
That is the absolute crux of the issue. This kind of technological fusion might create an exceptionally capable cyborg, but it does not automatically guarantee digital immortality or solve the problem of subjective identity.
We're expanding our functionality, our agency.
But we are not necessarily transferring or merging the subjective experience itself, because that experience is rooted in the emergent complexity of the biological system, the whole orchestra.
You have to make that vital distinction then. Is the connected self an expanded self, or is it just a self with a really, really smart calculator attached to it?
And if the feeling of self arises from the complex emergent dynamics of my specific biological body monitoring brain, the whole orchestra, then just copying the data or connecting the processing power doesn't automatically copy the feeling of being me.
The hard problem just laughs at the singularity.
It does.
So we might become an ultra-smart cyborg, far exceeding human intellectual capabilities, capable of these incredible feats of agency. But Nagel's original problem just persists.
It's still there. The question, what is it like to be an AI-connected human, which is just a new kind of highly evolved, technologically augmented bat, would still remain unanswered.
Functional enhancement without ontological merger. Okay, so if consciousness is this emergent property of the whole brain network, as we've been discussing, what does that dynamic process look like? Not when we try to build it, like with the AI, but when we watch it actually start.
Right, and this moves the debate out of the philosophical ivory tower and, well, straight onto the operating table. It forces us to confront the question of consciousness at the very, very beginning of life.
We're moving from the technological frontier into bioethics.
We are. And here, the problem of subjective experience runs headlong into these incredibly difficult decisions, forcing us to examine what we actually mean by consciousness. And a common way to do that is by using pain perception as a critical criterion.
The idea being that pain is the baseline. If a being can suffer, it must be conscious.
It's a very common and intuitive standard.
So what does the medical data actually tell us about when conscious pain begins? Is there a clear line?
Well, the consensus, though it is still debated, generally holds that the thalamocortical connections.
Okay, what are those?
Think of them as the neural superhighway between the deep feeling centers of the brain, the thalamus, and the higher processing centers, the cortex. And those connections are thought to become functionally online or connected roughly between 24 and 28 weeks of gestation.
And that's the point where the higher brain centers can potentially process a pain signal as suffering or as a subjective experience, rather than just a simple reflex action.
That's the idea. It's the difference between a raw signal and a cognitively processed experience.
But modern medicine, medical advances, have pushed the survival limit for premature infants below that 24-week marker.
Exactly. And this creates a profound bioethical paradox. With modern neonatal intensive care, these premature infants, often called micropreemies, can survive as early as 22 or 23 weeks. We have the technology to sustain their biological life.
But we aren't necessarily certain that the subjective experience of that life has fully emerged yet.
And that's the dilemma. So if you take the strictest definition, that conscious pain, meaning pain that involves cortical processing, is the absolute standard for consciousness, then a 23-week-old infant is biologically alive, but if those thalamocortical connections aren't functionally ready yet,
Then, by that very definition, the infant technically lacks consciousness.
it creates a deep and frankly very unsettling contradiction. We observe basic withdrawal movements. If a doctor has to draw blood from a preemie's heel, the foot pulls back.
Right.
The crucial question is that movement a mere brainstem level reflex, a programmed response that happens before any feeling even registers? Or is it conscious suffering that involves the cortex?
This forces us to really clarify our terms. Are we looking for sentience, or are we looking for what we might call higher consciousness?
We have to differentiate. Pain may be a marker of basic sentience, which is the capacity to feel and react to stimuli. This would be a kind of core consciousness.
It's the basic feeling.
The basic feeling. But that's not necessarily a marker of the higher consciousness we associate with the adult mind, the ability to reflect on the experience, to judge it, to store it as a narrative memory. The preemie might feel something in a very rudimentary way, but lack the neural architecture to experience suffering in the complex way an adult understands it.
The sources raise a very difficult comparative question here. Should we view these 22 to 27-week preemies who have this low emerging awareness in a similar way to patients in a persistent vegetative state, PVS, who have a low fading awareness?
The comparison is essential for clarity, but the differentiation by directionality is the key ethical and biological insight here.
Directionality, the direction they're heading in.
Precisely. At a single moment in time, a snapshot of their functional brain activity might appear superficially similar, but their internal trajectories are polar opposites.
Okay, so let's detail that difference, because it feels like it fundamentally changes the ethical calculation.
Well, the PVS patient is what we could call the fading mind. They exhibit wakefulness, their eyes might be open, but there's no clear awareness. Their neural system is static, or more likely declining, often due to massive, irreversible brain damage. The system is heading toward disconnection and entropy.
It's winding down.
It's winding down, but the preemie is the emerging mind.
It's winding up.
Exactly. The preemie exhibits wakefulness, yes, but its awareness is nascent, it's primitive, and it is rapidly organizing. The key is that the brain network is dynamically expanding. It's forming billions of connections per minute as it seeks to stabilize and integrate itself. This state is defined by becoming. The system is actively building coherence.
So the conclusion here is pretty profound. The preemie is not a fading fire that's going out. It's more like an unlit or flickering fire that is rapidly building its fuel and its organizational capacity. It's a developmental state.
We would define their state as a proto-consciousness or a core consciousness that is actively, purposefully developing. To label them simply unconscious is biologically inaccurate because their entire biological purpose at that moment is the creation and expansion of consciousness.
This really forces us to accept that consciousness has to be a spectrum, not an on-off switch. It's not a simple 0 or 1. A micropreemie isn't 100% conscious, but it's certainly not 0% conscious either.
It has to be a spectrum, and one defined by layers. If we define consciousness only by its highest functions, things like judgment, conflict resolution, or interpreting the world, then that higher function is simply not yet needed in the infant.
Its priorities are elsewhere.
Completely. The infant is entirely focused on unconscious life activity, breathing, regulating its temperature, and the fundamental biological struggle for homeostasis.
So we can use that proposed distinction to resolve this dilemma. Core consciousness versus extended consciousness.
Right. Core consciousness is the base layer. It's the sense of here and now, the basic feelings of being alive, hunger, temperature, discomfort. This is almost certainly present in the preemie as it monitors its own internal states.
But it lacks extended or narrative consciousness.
Exactly.
Right.
That's the ability to connect the past and the future, to engage in self-reflection, to make complex judgments. That is the part of the consciousness cake that is still being baked.
So a subjective experience is occurring at that core level. The baby is feeling its existence, but the mechanism for self-reflection on that experience, for that internal voice to say, I am aware that I am hungry and I remember being hungry yesterday, that is still under construction.
And now we can take that spectrum idea, the idea that consciousness starts with the most basic function of just being alive, and run it through a really radical new framework, one that links consciousness directly back to the simplest imperative of all, biological survival.
And this is Anil Seth's fascinating work in his book, Being You.
It is, and Seth's central premise provides this incredibly powerful counterargument to the singularity futurists we were just talking about. He argues that consciousness is fundamentally related to life, to homeostasis, not just to intelligence.
So we're shifting the entire focus of the question. Instead of asking, is this machine smart enough to be conscious? Seth is asking,
Is this machine alive enough to be conscious?
and he calls this the beast machine. I love that phrase.
It's a great phrase. The brain's fundamental purpose, Seth posits, is self-regulation and survival. Its job is to keep the delicate internal balance of the body's stable homeostasis, and above all, avoid death. We possess consciousness because we are actively struggling biological entities. It's an expensive tool that evolved to help the body survive.
Okay, so this immediately reinforces why an intelligent AI in this framework remains a smart P-zombie.
It does, because AI, no matter how intelligent it becomes, lacks that existential imperative. It doesn't have to monitor internal bodily states. It has no heartbeat, no blood pressure, no hunger pangs. And crucially, it has no biological need to fear its own oblivion or death.
If consciousness is a mechanism that evolved for biological survival,
Then the AI cannot achieve true human-like subjective consciousness because, in Seth's memorable phrase, no body, no mind.
it's missing the biological struggle that generates the subjective experience in the first place. It can have all the agency in the world, but it lacks the necessary substrate for experience.
Precisely.
So let's delve into how this beast machine actually perceives the world. Seth argues that our experience isn't a passive reception of reality at all. He calls it a controlled hallucination.
This is a really radical concept, and it's based on an idea called predictive processing, or PP. The theory is that your brain does not passively wait for sensory data to arrive from your eyes and ears to tell you what the world is.
It's not just a camera.
It's not a camera. Instead, it's constantly running an active internal simulation. It predicts what should be out there and what should be happening inside your body based on all your past experiences and current conditions. Sensory data from the world then only serves to correct the errors in that prediction.
So the brain is running this sophisticated internal simulator, and the outside world just provides the necessary updates to keep the software aligned with reality. When the prediction is accurate, your conscious experience is smooth, but when there's a big error.
That's when you pay attention. That's when consciousness really kicks in to solve the problem.
And this theory provides a beautiful mechanistic explanation for Nagel's original problem of perspective dependence.
It really does. The bat's world is a controlled hallucination built upon time-delay ultrasound models, and it's optimized for its specific way of survival. The human's world is a controlled hallucination built on the narrow visible spectrum of light and our relationship with gravity, optimized for our survival.
Both are subjective experiences designed to manage errors and help us survive. But the quality of that experience is entirely different because the predictive models and the sensory inputs are entirely different.
Exactly. And central to this whole idea of the beast machine is the internal feeling that starts it all.
Interoception.
Right. Seth argues that consciousness and the subjective feeling of the self itself fundamentally stems from interoception, the sense of our internal bodily states, your heartbeat, your hunger, your blood pressure, tissue damage. This interoceptive awareness is the absolute basis of all feeling and selfhood, because the most important thing for the brain to predict and control is the survival of the body itself.
I am conscious because I am fighting to live.
That is the core of his argument.
This theory is incredibly compelling. It grounds this very abstract thing, subjective experience, in concrete biological necessity. But the sources we looked at include a pretty significant critique that we have to acknowledge, one that brings us right back to the explanatory gap.
Yes, the critique is vital. Survival explains the purpose of consciousness, the why we have it. But it doesn't fully explain the quality, the what, of the subjective experience itself.
Meaning, if consciousness is just about minimizing prediction error for homeostasis, why does that error correction feel like the color red or the sound of a specific cello note?
Precisely. Other animals are also struggling for survival, yet their consciousness is clearly structured differently than ours.
So the theory needs some refinement when it comes to the origin of qualia. Internal sensations are the crucial input data for the machine, but they don't explain the subjective feeling that results from processing that data.
Correct. So the refined consensus suggests that internal sensations are the crucial input. They provide the necessary metrics and the emotional grounding. But the central processing unit that interprets and constructs that data into a meaningful subjective experience, the qualia, is the brain's complex neural network.
So consciousness doesn't originate from the heartbeat itself.
It originates from the connection between the brain and the sense organs as the brain relentlessly models those inputs. The brain is the complex emergent engine. The body provides the fuel and the essential metric of selfhood.
And this refined model aligns perfectly with the developmental stages we were just discussing, the layers of the self. It almost feels like you can overlay this beast-machine idea onto a kind of Freudian structure.
It's a really insightful connection, and it shows consciousness as this layered evolutionary achievement. You can actually trace the emergence of Seth's beast machine concept through these known milestones in developmental psychology.
Okay, let's trace that layered structure, the consciousness cake analogy we used before.
All right, so the very base layer, the sheet of the cake, is the bodily self. This is the proto-consciousness we talked about in the preemie.
The survival-focused internal monitoring without any self-reflection.
The primal id, if you like. It's purely focused on life functions, on homeostasis.
Then layer 2 is when you start to recognize the difference between the self and the rest of the world.
That's when a child typically passes the rouge test, usually around 18 months old. They see the spot of rouge on their nose in the mirror and touch their own nose, not the mirror.
They recognize themselves as an objective object.
Yes. And this marks the development of the perspectival self, which aligns with the ego, the self, as a stable center point of observation within the world. This is the frosting on the cake.
And finally, the highest layer, the one that is uniquely human.
This comes around 6 years old, and it coincides with the onset of sophisticated inner speech and a robust narrative ability. This is the narrative self.
The self-reflecting, storytelling, time-traveling self.
Correct. And this relates to the completion of the ego and the establishment of the superegos. These are the complex decorations that make the human consciousness cake so unique.
So the key takeaway here is that consciousness is a layered structure. The 22-week preemie is busy baking that essential base sheet of selfhood life, feeling, core interoception. It has the subjective feeling in its most basic form, but the fully realized adult human consciousness is this multi-layered structure built on top of that struggling, surviving beast machine foundation.
So now I think we're positioned to really understand the current landscape of research. And while the bat still flies and the zombie still walks, meaning no single unified theory of consciousness is accepted,
We're still grappling with the hard problem.
we are, but the academic conversation has matured significantly. Our sources identify 4 major theoretical frameworks that currently dominate the discussion.
And these 4 frameworks are the modern attempts to finally bridge that explanatory gap. And they each focus on a different aspect: structure, function, content, or survival.
Let's start with the functional approach, which is heavily reliant on our understanding of things like attention and conflict. This is global workspace theory, or GWT.
This is the broadcast station analogy, right?
Yeah, exactly. GWT, championed by Bernard Bars, views the brain as having these countless, specialized, unconscious modules, visual, auditory, motor control, all processing information in parallel, like specialized staff members in a big organization.
And they're all doing their own thing, unconsciously.
Right. Consciousness emerges when a piece of information, perhaps one that's causing a conflict or requires a global solution, gains sufficient attention to be uploaded or broadcast to the central global workspace.
So consciousness is what happens when the whole system needs to know something important, and that information has to be integrated across all the specialized areas.
Precisely. Once that information is in the workspace, it becomes globally accessible, and that allows for high-level flexible processing, the interpretation, the judgment, and the conflict resolution that really define higher human thought.
So this framework strongly supports the idea that consciousness is mobilized for conflict. We don't need to be consciously aware of simple, routine tasks, only the complex ones that require the entire brain to coordinate. Okay, next up is the most mathematical, the most structural, and I would argue the most ambitious theory out there: integrated information theory, or IIT.
IIT, developed by Giulio Tononi, attempts to move beyond just function and actually measure consciousness itself as if it were a fundamental physical property, like mass or charge.
And its core idea is that consciousness is related to the degree to which a system can integrate information while at the same time maintaining differentiation.
And this is where that Greek letter phi comes into the picture. It's supposed to be the actual mathematical measure of consciousness.
Which sounds a little bit like science fiction.
It is an incredibly audacious claim, which is why it receives both enormous praise and very deep skepticism. Phi mathematically measures how irreducible a system is. So if you have a system with high differentiation, like a library with millions of disconnected books, but low integration, the books aren't cross-referenced or connected at all.
Its phi value would be very low.
Very low, or even zero. A random pile of sand has 0 phi. A simple circuit board has a tiny, tiny phi.
So to get a high phi, every part of the system has to be able to affect every other part. But those parts can't just be redundant copies of each other.
That's the key. If you remove any single part of the system, the overall coherence and information processing capacity of the whole thing must drop significantly. It has to be an irreducible whole.
This strongly supports the idea that consciousness is an emergent phenomenon of the entire network, and it explains why deep sleep or anesthesia, which we know disrupts that large-scale integration, reduces consciousness to near zero.
And it provides a very clear mechanism for the consciousness spectrum and the preemie dilemma we were talking about.
So?
Because it treats consciousness as a continuous spectrum. A 24-week preemie might have a very low but non-zero phi value because its neural network is just beginning to organize and integrate basic information, whereas a sophisticated AI running on separate processing cores could have massive functional capacity, huge agency, but still have a phi of 0 because its integration level is compartmentalized, not holistic and irreducible.
Okay, moving on. Let's talk about the framework that really emphasizes metacognition, or thinking about thinking. Higher order theories, or HOT.
HOT argues that a sensory state only becomes conscious when there is a higher order thought or a metacognition about that state. It's not enough to just have the raw sensory input.
So simply having the neurons in my visual cortex register the color red isn't consciousness. The state only becomes conscious when I have the internal thought, I am aware that I am seeing red.
Yes. The difference is that internal monitoring mechanism, the executive function that labels and processes the raw data. And this links us directly back to the idea of the narrative self.
Right.
Ati-Supper supports the idea that narrative consciousness, the presence of inner language, the ability to reflect on one's own mental states, which we see emerging around the 6-year mark in development, is crucial for the fully developed human type of consciousness.
And this also seems to directly address the limitations of Nagel's bat, doesn't it?
It does. The bat certainly has the experience, the qualia, of echolocation. But if the bat lacked the complex neural architecture for higher-order reflection on that experience, does it possess consciousness in the fully human sense? HOT would suggest that without that higher-order thought, the experience might still be present, but it's not conscious in the full human self-aware narrative way.
Okay, and finally we revisit the one that ties everything back to that biological imperative.
Predictive processing, PP, the beast machine concept.
Right, as championed by Anil, Seth. The brain as a prediction error minimizing machine.
And consciousness is simply the functional and subjective result of this ongoing tireless process rooted most deeply in interoception, the monitoring of internal body states and the fundamental struggle for life.
So what does this framework offer that the others, with their focus on high-level integration and reflection, might miss?
PP provides the strongest backing for the claim that even without sophisticated judgment or language, even without a hi-fi or a global broadcast, the fundamental feeling of being alive and struggling constitutes a form of core consciousness.
It moves the focus away from abstract thought and puts it right back on the biological body.
It does. It supports the idea that the 22-week preemie, by virtue of its struggle for homeostasis, is already fundamentally conscious at that core interoceptive level.
You know, what's beautiful about this current landscape is that it feels like these theories aren't necessarily mutually exclusive.
I think that's right. The brain might be a system that achieves high integration, that's IIT's phi, and it uses that capacity to broadcast crucial information to the whole system, that's GWT, and then it uses higher order thoughts to reflect on that information, that's HOT.
And the entire system is being driven from the bottom up by the biological imperative to minimize prediction errors and survive.
That's key P. You can see how they could all fit together to describe different layers of the same phenomenon.
We have traveled a really vast distance in this deep dive. I mean, we started with that philosophical wall erected by Nagel's irreducible subjective nature of the bat.
Then we explored the technological limitations of the singularity and why functional connection is not the same thing as ontological merger.
And then we navigated the profound ethical complexities of the pre-me and the idea of consciousness as an emerging spectrum.
And I think what we've synthesized through all this complex material is a much more nuanced, layered view of consciousness. The most compelling modern perspective really does seem to integrate these ideas.
That consciousness requires a specific structural foundation, this irreducible integration from IIT, in a fundamentally biological, struggling body from PP.
But it achieves its final recognizable human form through this functional engagement of the global workspace, GWT, and this narrative reflective development that you get from HRT.
Yet even with these four powerful frameworks and decades of neural research that have mapped the brain down to the cellular level, we are still fundamentally bound by Nagel's original problem.
Absolutely. We can map the structure, we can measure the integration, we can trace the function, but the question of the feeling itself, the qualia, that remains the open gap.
We've created these incredibly sophisticated objective tools to describe the container of experience, but the subjective contents remain intensely personal and ultimately elusive.
We are getting closer to understanding the how and the why we have consciousness, but the what it is like remains entirely perspective dependent.
Which leads us to the final provocative thought for you to consider based on that beast-machine framework we discussed.
If consciousness is a controlled hallucination that was designed purely for survival, to manage the prediction errors in our volatile, mortal, struggling bodies, and technology is constantly advancing to stabilize and optimize our physical bodies, removing that constant biological struggle for homeostasis.
So if the beast is tamed by technology, if we reach a state of medical and technological perfection where death and disease are almost entirely managed and struggle is minimized, what then?
Will future generations of humans have a less vivid, a less intense, or perhaps a fundamentally different kind of subjective experience than we do today? What happens to the beast machine when the fight for life is finally over?
That's something to mull over.